Good day. My name is Bill Friedman. On behalf of Appcito, I'd like to welcome you to today's webinar using application delivery to drive DevOps agility. Sometimes you can learn new DevOps techniques by just hearing about them. Sometimes it takes seeing them in action. Today, we're fortunate enough to have cloud computing analyst Janakiram, MSV, who's going to both tell and show how to use application delivery to drive DevOps agility. I'm pleased to introduce today's speakers. Siva Mandalam, Vice President of Product and Strategy at Appcito, and Janakiram, MSV, Cloud Analyst, Architect, and founder of Janakiram & Associates. Siva is responsible for Appcito's product vision and solutions. Before joining Appcito, Siva provided leadership for Cisco's security business and F5 Networks application delivery controller product line. As an analyst and technologist who still designs and builds production applications, Janakiram, MSV, is uniquely qualified to speak to today's webinar topic. Johnny currently writes about cloud computing and DevOps for Forbes.com. Previously, he was the analyst covering technology for GigaOM Research and held technical and leadership positions with Amazon Web Services and Microsoft. Let me turn it over to Siva Mandalam. Siva?
Thank you, Bill. And thank you, everyone, for joining today's webinar brought to you by Appcito. At Appcito, we believe that there is a fundamental change in the way applications are being built, deployed, and managed. This is really driven by several market trends, including cloud computing, the DevOps processes, the increased prevalence of microservices architectures, the agile teams, and global operations. To support our business outcomes of agility and innovation, we believe the application delivery must change as well. That is the fundamental idea that is driving Appcito. Appcito Cafe provides unified application delivery services for elastic load balancing, cloud application security, and application analytics. And at Appcito, we're delivering these unified services as a single package, which is easy to deploy, a cloud-native service with an attractive consumption-based pricing model. Importantly, Appcito Cafe services scale up and down based on real-time application analytics to improve performance, security, and availability of the cloud applications running in your public, private, or hybrid clouds. As you listen to today's speakers, I invite you to think about your current approach to application delivery. Is it making your business more agile? Is it aligned with your current technology investments? Does it improve your user experiences? Talk to Appcito about how to get started on an improved path. Here now to speak on using application delivery to drive DevOps agility is Janakiram, MSV. Johnny?
Thanks, Siva. Good morning, good afternoon, good evening to everyone. It's my pleasure to be a part of this webinar. As I walk you through the challenges involved in optimizing front-end delivery and how Appcito is solving the problem, I'm going to touch upon various aspects of optimizing the applications. How do you extract the last bit of performance from your cloud deployed applications? And what is the art and science of managing front ends? What is the challenge and the cost involved in managing these front ends, and how exactly Appcito is attempting to solve these problems? So beyond being an analyst and an author, in my past life, I have managed complex, large cloud deployments of enterprise customers and web-scale startups. And one of the challenges that we have always faced was the cost involved in optimizing the front end. And this was taking a significant amount of time and the dollars spent on migrating applications to the cloud. In fact, I always used to articulate to my customers that there are two major milestones of cloud migration. The first one is lift and shift. That's actually the easier one. The second one is optimizing your application for the cloud and getting the best out of your cloud investments. There are many aspects in cloud optimization, all the way from choosing the right instance type and switching to the right commercial model and so on. But within the optimization task, a significant amount of time and energy is spent in optimizing the front end. It doesn't matter how well the application is architected, but it has to be optimized at the production level after it goes live, and that is the post-production optimization. And unfortunately, this has nothing to do with the optimization that the developers and the architects have implemented. So that's exactly what I'm going to focus on today's webinar, how you can leverage the existing toolkit and the platform to optimize your front end. So web application performance really matters. If you take some of the Fortune 100 companies who are making it big on the cloud and web, for them performance really matters. When it comes to Google, a very tiny 500 millisecond slowdown results in 20% of ad revenue, which is pretty huge and significant. A 2-second slowdown reduces Bing's query and click to 2.5% with every 2-second slowdown. Again, that's going to be costing Microsoft a lot of dollars. And for Amazon.com, the largest online retailer, 100 millisecond slowdown results in 1% revenue drop off. For the line of business that they are in, again, this matters quite a bit. And for Yahoo, 400 milliseconds of load time the improvement is resulting in 9% of traffic increase. Again, pretty significant. So don't think this is just applicable to the large brands and the big web scale companies. Web application performance matters to everyone, whether you are in the business of delivering content or selling online products or delivering media. Optimization and extracting the last bit of performance from your application is very, very important. So what is the art and science of managing the front end? As I mentioned earlier, there are two broad milestones or phases in your journey to the cloud. The first one is deploying the application, but the second one is performing various tasks across multiple layers to manage the performance. So the three key aspects when it comes to optimizing the front end is performance optimization of the front end layer, securing the front end layer, and constantly keeping an eye on the front end layer. But what exactly is the front end layer, and how do you isolate this from the rest of the application? Again, as I mentioned earlier, you may have some of the best practices baked into your application. Your architects have spent a lot of time making sure that they are designing a cloud native application. Your developers have followed every possible best practice in developing the application. But that's just one side of the coin. The other side of the coin is left for the sysadmins and the DevOps teams to fine-tune the remaining layers of the application. And they have a lot of knobs to turn, lot of levers to pull, and lot of sliders to drag. And only after they have done all of that, the application will reach its optimal level, right? And if you look at the tasks that the DevOps teams and the SysOps teams perform, these are the three things that they are focused on. And unfortunately, this is not a one-time task. It's a recurring, iterative experience of managing the front ends, right? So let's understand a bit more about each of these three aspects of managing front ends. When it comes to optimizing the front end, there are various layers. And again, the nucleus of this diagram, as you see, is the core application. But once the application is deployed, then you have to set up elasticity. Otherwise, there is no point in moving to the cloud. So configuring auto scale groups and launch configuration and making sure that you are setting up the right thresholds in the CloudWatch alarms, all of that is about elasticity and defining the auto scale capabilities. And majority of the customers who deploy their applications on Amazon use auto scale capabilities. And again, it is pretty laborious, and also you got to be aware of many capabilities and many tweaks to get the best out of your auto-scale configuration. Auto-scaling works in conjunction with load balancing. Obviously, it's a load balancer that's going to route the traffic to all the application servers, and auto-scale groups work hand in glove with Elastic Load Balancer if it is Amazon Web Services. But Autoscale and ELB are the managed services that you have on EC2. The real fun begins beyond that. For example, if you are delivering a lot of static content like documents, PDFs, images, videos, and so on, you don't want to go and hit the static content servers all the time. You might want to cache them, right? And similarly, you might want to use reverse proxy for reducing the burden on your app servers and web servers. And you have to implement custom compression based on the MIME types. The way you compress an image versus a video stream versus a document, and minifying your JavaScript and performing a lot of optimization on the content type is compression. And again, that in itself is a task that DevOps spends a lot of time on. And finally, there is throttling. You never want abusive customers or abusive traffic to take down your deployment. So you may want to implement certain policies and rules that will gracefully throttle the execution without making it very abrupt. You really don't want to block the legitimate traffic just because it's originating from a set of IP addresses, or you don't want to be taking any risk in dropping the traffic. But throttling lets you tune that pretty gracefully, so without really coming across as something abrupt. So these are the tasks that go into optimizing the front end. And though it looks like a simple slide with a strange diagram, go and speak to any DevOps team that is managing production web scale workloads, and they'll tell you what it takes to implement each of these layers. And again, what I want to underscore here is it has very little to do with the core application. The core application remains the same, but these tasks will change as you start expanding your footprint and as you start attracting more traffic. The next one is, of course, security. Amazon offers you security groups, but they are very primitive. Of course, you can go ahead and implement network, ACL, you can implement the security groups, and you can use in conjunction with VPC capabilities. But again, that just doesn't cut for a lot of production critical sensitive applications. You need a professional firewall that goes beyond the basic primitive security groups. You want to implement policies that are much more complex than whitelisting and blacklisting a set of IP addresses. And you want to make sure that your deployment is protected from DDoS attacks and unwanted attacks and traffic from the bots. The moment a service becomes popular, you automatically become the target for bots and DDoS attacks. And it is going to cost you a lot if they are not prevented. The third aspect of securing the front end is SSL termination. Though SSL offers you a lot of benefits and it is almost a mandatory checkbox that you got to click, it also unfortunately interferes with the performance. So in a lot of cases, customers offload the SSL termination to a layer of front-end servers that reduce the burden on the core application servers and web servers. But configuring that is going to be very tricky, and it is not meant for faint-hearted. You got to take a lot of precautions when you're offloading the SSL termination. And if you're using ELB, it becomes much more complex. And it is equally complex if you're using a do-it-yourself approach of using your own SSL termination servers. So these are the key aspects of securing the front end. And again, I may be simplifying this, but in reality, when it comes to configuring, they are pretty complex and pretty intense tasks. Finally, you need to constantly monitor the front end. And since the front end is almost the gatekeeper, you don't want the gatekeeper to die and become unavailable, right? And that will basically block the availability of your application. In the initial days of cloud and infrastructure monitoring, a lot of DevOps professionals relied on tools like PagerDuty. But as the complexity grew, they don't just cut it. They become very basic, and you need to go beyond the basic monitoring of URLs. Uptime, again, has many aspects to it, and you have to constantly keep an eye on the front end. So that is the availability aspect. Real-time traffic analysis is extremely important. And again, I have seen many customers rely on Google Analytics, but Google Analytics is meant for a very different use case and scenario. You want to have extreme insights into how your application is being accessed, where is the traffic coming from, what are the worst performing URLs, what are the best performing URLs, and so on. So you need to do that in real time. And of course, with DevOps becoming a core part of continuous integration and continuous deployment, you need to enable audit trail. You don't want someone to really fiddle with the front-end configuration or your DevOps continuous integration pipeline before even you realize. So enabling audit trail and making sure that you have enough checks there to make sure only authorized people are performing the DevOps tasks is very important. So audit trail will give you that ability to precisely find out who was responsible for a specific task. And finally, the classic good old log analysis. And we can't undermine the power of log analysis. Particularly when you're running an elastic deployment, you're going to deal with dozens of servers. And every server is going to generate a ton of log. And of course, there is a standard best practice for shipping all those logs to a central location and scrubbing them and analyzing. But you need a better engine that's going to take care of your front-end log management. So log analysis becomes very important. And all of them contribute to this single task, which is monitoring the front end. Unfortunately, when it comes to performing the tasks related to these three pillars, performance optimization, security, and monitoring, there is no single solution. You have to rely on quite a few point solutions that don't talk to each other, that don't understand each other, and I call that the spaghetti approach. So you might want to use HAProxy, Nginx for your load balancing and your reverse proxy. You might want to use Naxi for your security web application firewall, which is again an open source solution. And you might want to use mod security with Apache and your web servers. And for caching various types and again a partial reverse proxy, you might want to use Varnish, Logstash for consolidating your front-end logs and analyzing them, Nagios for your agent-driven monitoring infrastructure, OpsU for your analytics and visualization. And in my experience, I have touched upon all this, and we have gone through the pain of integrating this stack and delivering the right level of performance and experience to customers. The biggest challenge with this approach is you got to be a subject matter expert with each of these tools. And given the current talent crunch, take it from me, it's next to impossible to find one or two DevOps professionals who are good at least three tools of what you see here. You may get an excellent Nginx or a HAProxy administrator, but he doesn't know how to manage logs. You may get an excellent security expert who can really configure mod security and deploy Naxi, but he doesn't know anything about performance optimization. Similarly, log management is a task by itself, and you have experts just doing that. So the cost of managing this, just in terms of manpower, is going to be very, very challenging, right? And it's going to skyrocket over a period of time. And imagine if you're a managed service provider, you got to do it for hundreds of customers that you're going to manage over time, right? So to highlight upon the challenges of managing the front end, right? The first one is cloud resources. Even if you take just 3 tools, let's say you're going to set up Naxi and you're going to set up Nagios and HA proxy, you got to create a golden AMI and you got to create multiple versions of it and manage it, and it's going to be a big AMI sprawl. And on top of it, you will eventually get challenges to deal with things like Heartbleed. And once you have those, you got to go ahead and patch all of them. And that's not going to be easy. They're going to increase the downtime and they're going to interfere with the availability of application, which will impact your SLA levels. And this is not just for managed service providers, but even enterprise customers or in-house IT teams that are maintaining internal SLAs. So just the cost and the effort of managing AMIs and running EC2 instances and patching them is going to be a pretty expensive task. And then comes skill set, which I already touched upon. You need to have at least 4 certified administrators managing the point solutions and taking care of your entire deployment. And then there is a huge initial upfront cost involved in setting it up. Of course, you can use a lot of automation. You can use CloudFormation with a combination of Chef, Puppet, Ansible, and so on. But no one can underestimate the effort it takes to set up the first layer of front-end optimization. It's very, very laborious, cost-intensive, and error-prone. And that doesn't stop with that. There is a recurring cost to it. There is a recurring cost of managing, monitoring, patching, upgrading your front-end layer. And mind you, this has nothing to do with the core application. This is a value addition that you are bringing to your deployment or to your customer, and it's very hard to justify this cost. Now, coming to Appcitos. I don't work for Appcito, so this is not a pitch that I'm making. This is my experience of what I have discovered in Appcito platform. So for starters, Appcito is a SaaS platform that takes over your spaghetti do-it-yourself front-end optimization, and it goes beyond that. It essentially delivers load balancing. It's a great replacement for plain vanilla ELB, and it manages application security. It is a very cost-effective replacement for appliances that are available on Amazon Marketplace or Azure Marketplace. It's a WAF in itself, and it gives you real-time application analytics and replaces a variety of monitoring solutions that you have to deal with. And on top of it, Appcito also uses machine learning to predict and optimize your application over a period of time. That's the beauty of using data-driven decisions. So once Appcito understands the patterns and it has enough reference models, it applies machine learning algorithms to fine-tune the front end. So that's going to be very, very smart load balancing and smart performance optimization with very little intervention. So drilling down into the architecture, there are 2 layers of Appcito. Officially, Appcito calls them the control plane and the data plane. So the control plane is the centralized command center of Appcito. It is going to be common platform for all the customers deploying their applications on Appcito. It is responsible for managing the application delivery policies. So these policies are the rules, the rule definitions that each customers will define. So they define these policies and submit it to Barista, and Barista orchestrates them with actual deployment. And this is transparent to customers. In fact, you will not even notice that there is something called Barista unless you really want to go back to the dashboard and drill down into the analytics. So Barista doesn't come in between you and your deployment. It is the transparent behind the scenes layer that manages your policies and delivers the application performance management proxies and also gives you insightful analytics. So that is the common platform. And then it also delivers what is called as Appcito PEP, which stands for Policy Execution Proxy. This is where the rubber meets the road, right? So once you submit your rules and your application policies to Barista, they get translated into PEPs and get deployed into the same AZ, same region as your cloud application. It sits very close to your deployment and really takes over your load balancer, firewall, and literally becomes the front door to applications. So it will drive the policy execution proxies, ultimately responsible for applying those firewall rules and scale up, scale down policies. And the best thing is it assumes the context of the application. It becomes an integral part of the application. So there is very low latency between a PEP and your core app. And as you make changes to your application policies, they instantly get enforced because Barista is the orchestration engine that's going to push the changes to each of these PEPs. You will never have to deal with the PEP directly. You will remote control them through Barista. So that is the high-level architecture. And at this point, I want to introduce a real-world application called CloudShop. It's a fictitious e-commerce portal developed using real-world frameworks that customers use to go live. And this portal sells electronic gadgets, and it runs on Amazon. So behind the scenes, it follows certain best practices. Again, for simplicity and in the interest of time, I'm simplifying the architecture. So at the top, we have a DNS layer responsible for our domain name lookup service. That is pointing to the load balancer. And there are multiple web servers registered with the load balancer. And these web servers directly talk to a database cluster and also a cache. The frequently accessed data is cached. And for redundancy and high availability, we have the cluster spanning 2 zones. Translating this to an AWS deployment diagram, we are running this in AP Southeast 2, which is Sydney region. There's an auto-scale group that spans 2 AZs. And this auto-scaling group has our web app servers registered with an ELB. And the ELB is pointed by the DNS server. And we have dedicated security groups for cache servers, database servers, and database servers replicate with each other for high availability and redundancy. We have a master and slave configuration. The static content is stored in S3, and we have CloudWatch alarms set up for auto-scale. So that's a simplistic explanation of the deployment, and it's time for me to show you the actual demo. So let's switch to my portal. So here we see the e-commerce portal. I hope you are able to see the screen without the lag. So as you notice, this is a full-blown e-commerce portal developed using the best practices of cloud development and deployment. And this is not listening on the Elastic IP or the CNAME of the ELB. This is actually running on a URL called demo.cloudreadylabs.com. So demo.cloudreadylabs.com is my registered URL. And in fact, you can go ahead and type this URL in your browser and you can access this application. Don't initiate a DDoS attack. I haven't set up the policies for that. This is a very simple demo to point out the capabilities of Appcito. So let's work backwards to figure out the deployment architecture. So the very first thing is, let me go ahead and resolve this URL. So I'm going to ping demo.cloudreadylabs.com, and you'll notice that it's obviously pointing to an ELB. So that's an indication that this portal is running on AWS and front-ended by an ELB. Now, between this app and the ELB, I use a third-party DNS service, which is my favorite, which is called DNS Made Easy. We have used this for many customers and found that to be better than many dynamic DNS services. So here, for cloudreadylabs.com domain, I set up a C name for a subdomain called demo, and it is pointing to the ELB with a TTL of 10, because I want this to be pretty fast in propagation. So I set up a TTL of 10, and we have the DNS pointing to the ELB. So let me show you the ELB. So obviously we have ELB configured here, and this is the DNS name, and we have two app servers, ShopWeb1 and ShopWeb2, pointing to the registered with the ELB, and they are listening. They are running in two different AZs. Again, I'm following the best practices of AWS deployment. I have enabled health checks. I have done every possible optimization that I'm expected to do with this. In terms of instances, I have 8 instances, 2 each running in dedicated AZs. So 2 web servers, 2 session servers, and 2 database servers for high availability. That's pretty much is the AWS configuration. And now I want to walk you through the process of optimizing this application and securing this application through Appcito. So I come to Appcito. So you can actually sign up for the trial. Just go to appcito.com and you can sign up for your application. This is a wizard that's going to walk us through a series of steps. And for the first time, when I have seen this, I was blown away. And I'm not exaggerating. If you are in the business of managing front ends, you will truly appreciate Appcito like me. Don't take it from me. Just go ahead and sign up for a trial, and you will understand what I'm saying. So I'm going to type in my application name. So let's call this CloudShop, right? And I'm going to point this to my URL, demo.cloudreadylabs. And as you notice, these application servers can be hosted across AWS, OpenStack, Azure, or even your hybrid cloud or private cloud within your data center. So we use AWS since our application is running there. And then you can use Route 53 if your domain is registered with Route 53, or you could point it to other. Since I'm using a third-party DNS, I again follow a best practice of not keeping all my eggs in the same basket. So DNS is very fragile, and that can make or break your application. So I don't want to take chances. I don't want to put all my entities in the same AWS cloud. So I have moved out my DNS to DNS Made Easy. So I'm going to point it to other and eventually configure it. Okay, so now once we populate all these details, we click on the next step. So this is where I need to explicitly give permissions to Appcito. So Appcito will become your automated DevOps engineer, right? And in production environments, it's again a best practice to create an IAM role with very precise roles and precise operational checklist for your DevOps engineers. For example, you don't want your DevOps engineer to fiddle with PCI compliant credit card servers, where the customer data is stored. So you can exclude him from accessing it by creating an IAM policy. And you can only define what exactly you need him to do. And since Appcito is assuming the role of DevOps engineer, you need to define a role for this entity. So for that, we go back to IAM, and this is the standard IAM console. Click on users, and I've already created the role that will give explicit permission for Appcito to access my deployment. So this is the policy that I have copied and pasted from Appcito. So you can actually download this policy document, and it opens up in standard editor. Simply copy and paste that in this window where you are allowing Appcito to access certain elements of your deployment. For example, you are letting all access to EC2, which is actually a little bit of concern, but I'm told this is going to change very soon. So you need not give 100% access to EC2. That will change. And similarly, this will get 100% access to Route 53 because it's going to change the zone entries of Route 53. It's going to augment CloudWatch metrics, so it gets access to CloudWatch, obviously ELB, and it also gets some IAM capabilities and SNS capabilities, and finally auto-scaling permissions. So these are the precise touch points that Appcito will have within your deployment. So once we perform this, we go to the next step, and we actually give the access key and the secret key for this user. So this is the access key, and you can download your access key and secret key and paste it here. So this will ensure that Appcito accesses the same IAM profile based on what you have given. So I have already created the security credentials. I'm going to use that and click on next. Okay, in case I already have this, I can skip this step and move to my application infrastructure. So now this is performing a discovery. Again, this is very analogous to what a DevOps engineer would do manually. The very first thing that we used to do in our business was to send an Excel worksheet to the customer, asking what is the role of each service, who is the point of contact, and how often do they upgrade, and what is the AMI maintenance policy, and so on. And that used to be the discovery phase of our managed services. Interestingly, because of the metadata, Appcito also performs the same discovery. It figured that there is an ELB behind this domain, and that's exactly what our ping showed us. And if I'm not using an ELB, I can manually key in my application server IP. This is going to be the public IP, which is Elastic IP if I'm outside of VPC. This can be the private IP if I'm using a subnet within VPC. Now, I'm using an ELB, so I'm going to choose this and click on Map My Application Servers. Pretty smart. So Appcito has now discovered that I have Shop Web 1 and Shop Web 2 registered with my ELB. That's because it's able to query the metadata and extract the details. So it has done the discovery. And this is where it becomes more powerful. There is no scheme that you can use with ELB. But here, you can use least connections, which is one of the schemes of load balancing. You could use round robin and also define a weightage. For example, I'm running different instance types and they are not in auto scale. So I want more traffic to go to my M3X large and less traffic to my M1 large. So I can route the traffic based on the instance types and specifics based on my app server configuration. So I'm going to leave the default least connections. And the other interesting aspect here is the session persistence. So we are going to use session persistence because this will ensure that there's a sticky bit added to our traffic. So the traffic will always go back to the origin server that has initiated the session. Now again, ELB for a long time didn't have this, and it added this capability only recently. And by enabling session persistence, you're basically making the sticky bit available. The next step is where the action begins. So this is where you actually start applying the front-end optimization, and that process is called caffeinating, right? So it's going to take a little longer because this is going to impact our live application. So it says, congratulations, cafe service is being provisioned. And in some time, in few minutes, it's going to caffeinate our application, right? So now what actually happens is we got the ELB DNS, which is the CNAME of our domain. And now we have an alternative to that, which looks something like cafenode.pep followed by a long FQDN. So all you got to do is enable cafe. And once you do this, you are basically deploying the PEPs in your account, and they take over the front-end traffic. And then you got to make a change by grabbing this URL and updating your DNS. Now, to make this more realistic, I already have an application with real traffic and a real PEPs in place. So this is the cafe DNS that Appcito has recommended. So what I'm going to do is, again, I need not even go back to my application. I need not even touch my core application. In fact, if I'm using Route 53, this step will be automated. But since I'm using a third-party DNS, I'm going to grab this URL. Let me make sure that the CNAME is updated. Okay, so now I have quietly replaced my ELB with the cafe URL. And let's give it some time and ping this, right? And there we go. That's the beauty of managed DNS made easy, managed DNS. So now, earlier this was pointing to ELB, and now this is pointing to the PEP URL that came from our caffeination process. Let's go back to our portal and refresh. Your end users don't even realize. Everything remained the same. We never touched the core deployment. We never touched the client side of it. Everything remained the same. The magic just happened here, and of course here. That's the only link between your application and Appcito Cafe, right? And this is exactly what I liked when I first encountered Appcito. Once you use Appcito as your front end, you have a choice of going ahead and deleting your load balancer. By the way, it doesn't disrupt your existing deployment. Your load balancer is still active. It says both the instances are in service. That's because the load balancer doesn't realize that it has been gracefully replaced by an external front end. The only difference is this load balancer will never ever get the traffic. The traffic gets routed via the PEPs. So if you really want to save some cost, you can actually delete this ELB. And if you're not so cost conscious, you can leave it as is, because later on when you're moving the configuration, you can fall back to the same ELB just by changing the DNS name. So it's pretty straightforward. So let me take you back to the dashboard, right, and show you what it looks like when you have a production application in place. Let me expand the timeline and just give it some time for the data to get populated. Excellent. Okay, so now what I've actually done is I have emulated some traffic from BlazeMeter. So I ran a hosted JMeter test, a load test from multiple locations, just to show you how the data looks like. So I had some traffic coming from Japan. I can expand this. So I had some traffic from Japan, from central US, from India, and some anonymized locations, right? So I also have some traffic from Europe. So this is the geographical spread, and also gives me the high-level analytics of the operating systems, the browsers, and so on. And you can also get a very instant view of the worst behaving URLs. Now, it looks like one of my JavaScript is the worst performing entity in my cloud deployment. It gets more powerful when I click on the total response time. And this is the actual essence of Appcito Analytics. So if you notice, there is a color-coded coordinated diagram that says how the deployment is actually represented. So you have the client, and then there is a data transfer time to the PEP, and between the PEP and your core application, there is again a round trip, right? And if you map the color scheme to the chart that you see here, you can pretty much drill down into each of these things, right? For example, the purple one that you see here represents the client network, right? And the larger portion is the client access. And this is the app server network, which is represented in green, which is the traffic between the PEP and the core app servers. The thin gray line represents the time it took for the app servers to execute, right? And this is, again, a very powerful way of visualizing your cloud deployment performance, right? So it turns very interesting. And none of the analytics tools can give you a real-time view of how the traffic is impacting your deployment, right? And it also gives you the performance of each of the URLs. For example, the place that is really farther from the deployment. And currently, I'm running in Sydney, so obviously the traffic originated from US is going to take a longer time. So you can actually drill down based on the geographical spread. And you can also get insights into the geo distribution, the URL performance, and so on. So it becomes very, very powerful with more data that comes Appcito's way. So you have a few more analytics. So if you have 500 errors or 400 responses, you can analyze that here. And if you have SSL enabled deployments, they show up in this dashboard. So it's pretty powerful, right? And we are just scratching the surface. So that concludes our overview of caffeinating an application, where we have very gracefully replaced a plain vanilla Elastic Load Balancer with Appcito Cafe. So let me switch back to slides and summarize what we have seen so far, right? So for me, Appcito is a unified layer that effectively replaces 3 different implementations: a load balancer, either an ELB or a do-it-yourself load balancer, an expensive web application firewall, and insightful analytics. Those are the 3 that I get when I switch to Appcito. And as we have seen, it supports beyond AWS. You can use OpenStack, Azure, and support for other platforms is coming soon. So that is a quick summary of Appcito on what we have seen. And with that, I invite Siva back to talk about the capabilities and the roadmap. Siva?
Okay, thank you, Johnny, for that wonderful presentation, and also the demo for where you walked us through. I know there was a lot of questions actually on that. We'll just get to the questions in a bit, but I wanted to kind of summarize here. Click on that one more time, Johnny. I wanted to actually summarize the capabilities of Appcito Cafe here. So today we saw some demo and capabilities, availability on the sides on the availability and performance, focused on load balancing and content switching, and performance optimization, etc., and also some application analytics. In addition to this, we have security capabilities in the area of web application firewalling, DDoS protection, bot protection, elastic SSL capabilities, and the idea of actually doing blue-green type of deployments inside the context of your server environments. And the beauty of this is that all of this, we talked about it inside the context of the front-end load balancers. We have some of the production customers who are looking at us in terms of deploying it in front of like multiple microservices. And also we have container-based actually applications which we can be front-ending as well. So, i.e., I'm basically saying that this actually applies to the microservices as well as to the Docker containers, etc. So, pretty powerful stuff in terms of actually the capabilities. And if you go one more step forward, yeah. So with that, actually, we are back to Bill.
All right. So thank you, Johnny and Siva. And it's time now to turn the webinar over to the audience as we open it up for questions and answers. We've gotten many interesting questions for our panelists, and we will get to those in order. Many are coming in right now as well. We will have time for several of them all the way through to the top of the hour. So let's get started here. The first question is for you, Johnny. Can you elucidate a little bit more on how much effort is required to deploy multiple open source application delivery technologies, not just an ELB or something of that sort, but multiple in the cloud along with the cloud application?
Right. So I did briefly touch upon that during the webinar. So it really depends on the kind of solution that you handpick for your deployment. For example, the effort it takes to deploy HAProxy versus Nginx versus Maxi, for different use cases is very different. So the skill set that's required for managing these point solutions is very, very different, and it varies between one open source solution to the other. And unfortunately, the reality is no one open source solution fits the bill. You've got to use a collection of these open source solutions to achieve the optimal security levels and the optimal performance levels. So there is no one-line answer to it, unfortunately.
All right. Well, thanks for trying. One for you, Siva. Can you describe how Appcito Cafe provides bot protection?
Sure. So there are a couple of ways actually we provide bot protection. One is that the most commonly compromised actually IPs out there are loaded actually inside the context of the system where when you are getting packets from those IPs, when you turn on the policy saying that you want bot protection automatically, it's actually those type of IPs are malicious IPs. Traffic from the malicious IPs are actually deleted. In addition to that, we also actually roll rule set on a daily basis, which are updated on a daily basis, but it could be actually as updated as much as actually an hourly basis, which also provides you the ability to actually specifically screen out bot type of capabilities. The third thing which we do is the ability to actually learn the spurious connections actually come from a specific IP. And this we call the closed loop application delivery. For example, a single IP is actually sending in spurious amount of transactions or spurious amount of actually IP packets towards your application. We can actually time out and actually put that specific IP on a timeout, and then actually later come back and actually release it. The operator comes back and actually release it. So there are multiple ways in actually which we are providing actually the bot protection is the answer. Okay.
Good. Thank you, Siva. Johnny, question for you from Peta. Why wouldn't I just use an application delivery controller appliance to do all these capabilities and functions with my cloud applications?
Right. So you can, I think I also briefly mentioned that in the webinar. So you can go ahead and deploy a commercial appliance available in the marketplace, whether it is Azure or AWS marketplace. But that appliance, again, is designed to do one thing very well. You have appliances that do load balancing very well. You have appliances that focus more on security, but it's very hard to get the best of both in just one appliance, number one. Number two, the upfront cost of these solutions is pretty high. In most of the times, they defy the logic of using cloud because you got to launch an instance and then go and buy a license with a vendor. So that actually turns around the concept of cloud because you are using a combination of CapEx and OpEx. What I see in Appcito is it aligns with cloud native philosophy. It uses a SaaS model which translates to an OpEx model. So there is no upfront cost, and you can subscribe and scale as you go along. So that's a precise difference.
All right, next question is for Siva. The question is, so we saw the demo today in AWS. Can you share what other cloud environments or IT environments that Appcito Cafe supports?
Sure. In addition to AWS, we also are orderable and fully available in Azure, in OpenStack, and next week we will be in VMware. And For Google, I think that was one of the questions. Is something we're working on that. We have a container-based implementation, and we feel very confident in terms of actually making this available in Google in a short time. But really, the idea is that with our implementation, we can really actually work in any cloud and really maintain the capabilities, etc. There was one other question really on the SLA reports, which I would like to take it as well.
Go ahead.
So monitoring uptime and performance SLA. So monitoring actually is drill down capabilities, provide you a very detailed analysis from a performance perspective on not only the uptime, actually also the performance statistics. And one of the other things you can drill down actually to do from the performance uptime when you find problems is to drill down to actually get to log analysis and generate that. So these capabilities are used for generating or maintaining your SLAs. We don't produce an SLA report, but we do actually have an SLA for specific to our service. That's the answer to that question.
All right. It looks like we have time for one more question. I think so for Sivas, do you want to take this one? Someone asks, is the PEP running in my VPC?
Yeah, that's your choice. I think we support multiple deployment models. We can actually obviously run this all in our environment, and you could run it in your environment and kind of manage that and all that. So I think there's a lot of flexibility in terms of how you can deploy this.
Okay.
So there was another question here.
You have time for that?
Yeah.
Okay.
I got my own enterprise private cloud and appliances inside my network, and I'm running VMware. Can you describe how it would orchestrate elasticity and spinning up the new machines, etc.? So the answer to that is actually we use plugins in conjunction with actually the existing orchestrators to achieve that capability. Not only do we provide load balancing, which actually the question really asks for, but the unified services in terms of really providing load balancing, application security, application performance optimization, continuous deployment, all with the application analytics, big data style analytics. And that's kind of what is missing actually inside the context of the VMware environments, if you kind of actually know about that environment.
All right.
Any questions?
We are out of time. Those were some great questions, but it's time for us to wrap up. So I want to thank all of you for attending today, for asking great questions, and for your patience with everything we covered here. I also want to thank our speakers, Janakiram and Shiva. If you'd like to check out the products and services that you saw here today in the webinar, please call or visit us at appcito.com. We're happy to do personalized product demos. We have free trials available. Give us a call. Thank you.